Okay, so to start off with this activity here from what we had done as a class, which you'll be seeing the video on shortly. You should also see the previous video from 7th period on yesterday. Each of the groups got 9 dishes, which had nuts, bolts, washers, anything in them, etc. And their beginning question was, they had to figure out how these dishes of nuts and bolts represented different substances. In front of you right now is dish 1. Dish 2, 3, dish 4, dish 5, dish 6, dish 7, dish 8, and dish 9. Okay. Now we are going to wrap up our discussion from this activity with some notes from what we've already discussed on the board, and then also some more general notes from the textbook from the first section of Chapter 2. Lights, camera, action, gang. Here we go. Just in case you need your binder, Trevor. Let's see if I can get this centered. Yep, not a problem. Okay, that ought to be perfectly centered. Okay. Yeah, I'm recording live. I have been since I was up front there when I went over those dishes, if you saw me do that. So. All right, let's wrap this up. So, to start with, we've got elements, we've got compounds, we've got mixtures, but the thing is, we're going to need to break that up a little more. Okay? We're going to have to break that up a little bit more into what we particularly need to do. So now let's start with elements and compounds. Elements and compounds actually make up a broader category. How are elements and compounds kind of similar to one another? Is there any similarity that you can think of that makes them similar?
Elements are like compounds are made of elements?
Yeah, compounds are made of elements, okay? So in order to make a compound, we've got to have elements to do that. Now to start with elements, besides obviously just now here, where have you heard the term element before? Yeah. Bam! That's right. Periodic table of elements. Those are all the elements that we have on this planet. There's roughly around 110 elements on the periodic table. Most of them are found naturally on the Earth. Some of them are ones that have been created in a laboratory through simulations. If you've ever heard of a place called CERN in Switzerland, it's a place where they have all like the top-notch scientists in the world, and they have a big, huge tunnel underground that's like miles and miles long. It's a particle collider, and they've actually been able to recreate, I guess you could say, mini Big Bangs, and from that they've been able to detect traceable or traces of elements that existed long ago. Yeah.
And antimatter?
Yep. Yes. Because in physics, supposedly for all the matter we have on Earth, there is also the same amount of antimatter. I admit that's getting into theoretical physics, something I don't know a whole lot about, but anyway. So some of those elements that are on here, like, bless you by the way, Rutherfordium, Honium, Seaborgium, Niels Bohrium, named after different scientists. Niels Bohr is a scientist that has helped to give up information towards the model of the atom. Rutherford, another scientist that gave information towards the discovery of the atom. So a lot of these were named after scientists from the discovery. Neptunium, plutonium, So those are all elements that they may not necessarily, some of them may not necessarily actually exist anymore on Earth. Most of them do, obviously, but there are some of them where they have such a short life. I mean, and what I mean by that is when they're created in that colliding acceleration, they exist for like fractions of a second. They're detectable, but they don't last. So they think that it happened, that it came about with the Big Bang, and basically, in a sense, when the dust settled, those elements went away. They may exist in space. We don't really know for positively sure. But anyway, those are elements. Now, what do we know that everything is made up of?
Atoms.
Atoms, yeah. All of our mass, everything that's made up of mass is made up of atoms. That's why you can never believe an atom, by the way. It makes up everything. Okay, so elements can't be broken down any further for a reason. They're atoms. They are the different kinds of atoms that exist here on Earth. Can't be broken down any further. They're one kind of thing. They're specifically one kind of atom. And all those elements are different from one another. So now compounds are made of two or more objects. Specifically, they are made of two or more atoms. And they can be broken down. Now, there's a chemical compound I guarantee everyone in this room knows of. And you know the formula of it too. Okay. I guarantee that there's a compound that everyone in this room knows of. They may- You guys rock. I was just going to ask, what is that compound? Very good. Yeah, H2O. H2O is a compound. 2 hydrogens, 1 oxygen. There's your example of 2 or more atoms put together. 2 or more atoms put together. H2O. 2 hydrogen atoms, 1 oxygen atoms. Water. Makes up all, it basically helps sustain life. We need water. I think they said roughly around 70 to 80% of our bodies are water. So obviously, we need to make sure that we're intaking it. Here's to your health. As I'm drinking a little bit of hot water there. Okay? So yeah, that is a compound. Now, something that you may not have known about water is, yes, it actually can be broken down into its components, hydrogen and oxygen. Does anyone happen to know how?
Condensation?
No.
Isn't there like a machine that does that and it like gives electricity and then it goes and they split it?
So what's the thing that they actually have to use to break it apart?
It's like a box.
Okay, I'm not talking about the instrument, but what's the force that they have to use to break it apart that you were just saying?
Pressure.
What's that object do?
It takes the water and it splits the hydrogen and oxygen molecules.
This is a little machine here, electric. It's basically all it is, and I'll show you here for the camera people here too. You just heard me use this. No, it's not a taser, but what they do is they can actually put water into glass tubes, and I'll take that back. This would be the thing that they can actually take hydrogen gas and oxygen gas. When they take the hydrogen gas and oxygen gas and they create a spark, they can get it to turn back into water. But there's also, I've got another device, it's called an electrolysis apparatus, where literally you're hooking a positive electrical terminal with a negative electrical terminal. In other words, like 2 sides of a battery. You're hooking up those terminals to water, and when you turn on the juice, the electricity to it, you start seeing bubbles forming. Those bubbles at the positive terminal is oxygen gas. At the negative terminal is hydrogen gas. And you can test it because at the positive terminal where the oxygen gas is going to, if you put like a match to it or some type of a splint, what generally happens to fire in the presence of oxygen? Yeah, the flame will get bigger. Or with hydrogen gas, when you put a flame to it, you'll hear like a popping sound. Okay? So that's how you know you've created it. So electricity is the force that can break apart water, and it can take hydrogen gas and oxygen gas, and with that electrical spark, combine those two gases to turn into the chemical compound. Yeah.
So is it kind of like with the steam engine with the how when water gets hot it will start to steam and then they
That's something
compressed
else,
air?
and we'll talk about that
So we
later.
can
actually.
make water?
Yeah.
Cool. If we ever run out, we'll know how to get more.
We'll never run out.
Ever?
No.
How do you know?
We talked about it in the fall. We talked about it back in the fall.
Well, I forgot.
Ocean in the water cycle.
You know your
Thank you.
water?
The water cycle.
We're never gonna run
They
out
have
of water.
filters.
You can take salt
Now,
water.
okay, now in places they may, but it all depends on where. And remember, it also had to do with the weather. I'll just challenge you to go back and take a look at your notes from the water cycle.
Yeah, I remember now.
Okay. Go back and take a look at your notes from the water cycle. Anyway. So, elements, one kind of atom. Compounds, two or more atoms put together. They can be broken down. Elements cannot be broken down. Okay? Those two things together, elements and compounds, make up, obviously mixtures are something a little bit different, but elements and compounds make up a broader category called pure substances. Okay, so elements and compounds make up pure substances. That's the broad category. A pure substance, then, is something that has exactly the same composition. In other words, water is always going to have the same composition. It's always going to be two hydrogens, one oxygen. That's never going to change. An element is always going to be made of the same thing. It's going to be made up of certain kinds of atoms. Hydrogen is going to be made up of hydrogen atoms. Oxygen, oxygen atoms, etc. So it has the same composition and the same property. So every sample of a given substance, of a pure substance, that has the same properties and has a fixed uniform composition. So that's one of your notes there. And again, I'm just looking at the definition, top of page 39. So that is a pure substance. Okay, and then as we said, an element was one kind of thing, one kind of atom. Can't be broken down any further. Compound, two or more elements, and it can be broken down into those elements. And obviously it has a fixed proportion. That's one thing I wanted to add on to a compound. It has a fixed proportion. Again, like water, H2O. There's another thing that's a compound that we know of also in our everyday life. You use it to season your food. Salt. Does anyone happen to know formula of salt?
0572.
That's zero. Anybody?
It starts with H.
Does not start with an H.
Oh,
Does it start with an S? It's sodium.
Does not start with an S. It's sodium. Sodium what?
Carbonate?
Not carbonate, no. Sodium carbonate is what's known as baking soda.
Bicarbonate?
Or wait a minute, maybe I'm getting my thing. Oh, I'm sorry. Sodium carbonate is a what's known as washing soda. In fact, sodium bicarbonate, yes, is baking soda. Sodium carbonate is washing soda. It's an additive that you can use in your laundry. So that's the difference. Bicarbonate you can actually use to cook with. Just plain sodium carbonate, you use it as part of a washing your laundry.
Sodium
What do you want to eat? Huh? Sodium chloride. Yep. Whichever. I didn't know. So in other words, you didn't know it, that's okay. I didn't know it by chance if anyone would know it. That is typical table salt. The salt that most of us probably eat is actually NaI, also known as iodized salt, sodium iodide.
I have a question. What kind of salt would it be? What's sea salt?
That would be the plain NaCl, because you'll notice on sea salt, it'll have the label, does not provide an adequate source of iodine, a necessary nutrient. So we actually need a little bit of iodine in our diet, and hence that's why most salts are sodium iodide, so that way people can get that source of iodine that they need.
What would happen if we drink iodine?
I think that's a little bit of a different chemical. I think if I remember right, the chemical iodine itself is technically poisonous in terms of when you ingest it. Because iodine itself, normally you use as like a medical, like a first aid liquid to use like to heal your wounds. Has anyone ever had iodine put on them before that you know of? It's kind of like a brownish looking liquid, brownish purplish liquid.
Like turn my stomach brown.
Yeah. It's basically, instead of using, because there are people that are allergic to rubbing alcohol, so instead of using rubbing alcohol, you can also use iodine. Helps to clean up, like if you've got a cut or a wound, it helps to clean it up and heal it. Yeah,
What does iodine in your, like,
in your
what's it do
system.
for your, what's it do for your body?
Oh, no. Okay. Basically, it helps you to, any type of salt that you have in your body, we need salt for a reason, okay? Basically, take this for example, Gatorade. Okay, why do they have people drink Gatorade at sport, when you're competing in a sporting event, as opposed to just water? Now granted, you don't want to drink just all Gatorade, but anyway, go ahead.
Your sweat, so it pulls sodium.
Yeah, you're sweating it out, okay? After a while, let's just say if you keep drinking water and you continue to sweat and sweat and sweat, how do you feel eventually?
Terrible.
Yeah. Why? What do you mean, define terrible for me?
Dude, it almost feels like you're dehydrated.
Feels kind of like you're dehydrated.
It's not energizing because it just keeps going down.
Right, and it kind of zaps your energy. Well, the reason for that, we need Gatorade because it has basically a little bit of salt in it for us, which, if you've ever heard of the term electrolytes, I guarantee you've heard of that term. It's been used a lot, at least in reference to Gatorade. Electrolytes, in other words, salt, that is the stuff that we need for our nerves to work properly. We need that stuff for our nerves in order to conduct electrical impulses in our nerves. Basically, think of the nerves in our body like electrical wires. If you shut off the electricity to a wire, it won't go. If you slice a nerve, you can no longer move whatever part of your body that nerve is going to. So someone that has nerve damage cannot move parts of their body because it's basically the electricity is cut off to it.
Aren't there a bunch of nerves for one thing?
We have nerves going all over the place.
So then why if you damage like this one?
Well, It depends on how many, it depends on where it's at. Think of it as like, obviously, in certain parts of our body, think of them as like major electric lines. There's some that are major electric lines, they're gonna carry a lot of electricity. There's some that are gonna be minor, like say maybe one that goes to your house. What's gonna be worse, cutting a major electrical line that serves a bunch of towns, or just a line that goes to your house? Yeah. Now granted, it's a bit inconvenient, but at least it's not shutting off entire towns. In here, up and down our back, we have all of these nerves going up and down our back. That's called the spinal cord. The spinal cord leads up into the back end of the brain. The brain's kind of like the control center. It's like the power plant for us. It allows us to do anything. Yeah.
I rode the go-kart about 6 months ago,
Yeah?
and I can't feel this part of my arm. I went to the doctor for it, and they didn't really give me an explanation.
Okay. Well, it might be, do you remember where you hurt your arm at? Kind of in this area? It may be that you might have damaged a nerve. You have on your arm here 2 major nerves. One that is on this side here, known as the ulnar nerve, as this part, this bone right here on the pinky side of your arm is known as the ulna. On the thumb side is known as the radius. That side you have the radial nerve. Ulnar nerve, radial nerve. So you might have damaged one of those nerves, or maybe some of the branching offs of the nerve. Possibly. I'm not a doctor, so I couldn't tell you definitively, but you may have. Okay, anyway, wrapping this up and continuing here. Mixtures. Okay, mixtures. You know what? I've got 8:53. I've only got 2 minutes left. I'm going to call it a day on that. I want to finish going over these notes on Monday. But what I'm going to do is I am going to give you the assignment. It's an easy assignment. It's just flat out basically a book worksheet assignment. Something I think you can very simply do. And then we can finish going over this on Monday. And then we'll also go to section 2 on Monday. Okay? I'm going to shut off the video and I'll hand out the paper.
Well, I'm good for this.